record, because we don't quite have everybody here. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of you are here. Oh, I think we've only got 16, so we're almost full class. But so the question was, before we started recording, do you have to put things in interval notation? I haven't really decided yet, but I think the hardest thing will be where you need to add the k pi or the k2 pi or whatever when we're not limiting our answers. So that that'll be the hard thing, I think, for students to remember, is especially if we don't limit our domain. Or like that one quiz question that we did limit our domain, but we had to go outside the domains, because then when we divided it by 2, then we were back inside the domain. So I may or may not ask for interval notation, but I'm sure. I think the bigger thing is make sure that you remember that multiples of pi, if it's a tangent, multiples of pi are going to work, and if it's a sine or cosine, multiples of 2 pi will work. That'll be the harder thing to remember, I think. So, did I answer your question, Brian?
Yeah, I think so.
Okay.
Thank you.
All right, what other questions do you guys have?
I have a question.
Go ahead. Go ahead.
Yeah. So last time when I was doing it, I was confused if I was supposed to put some of the answers in the test.
So I heard you say you were confused, and then you trailed off, and I couldn't tell what you were saying.
Oh, that am I supposed to write all my answers in the paper and then just take a picture and send it to you, right? That was the correct way, or did I do it wrong?
Yeah, that was the correct way. So it seems like last time a few people had trouble getting it in within 15 minutes, and so this time I'm going to give you the full 30 minutes to make sure you can take your screenshots and everything. What I will say is, yeah, I mean, if you write everything out on your paper, I will look at your paper and then I will give you credit for it. But it was nice for some people. Some of you found an equation editor, which I was shocked about. I think I gave you an extra credit point for using the equation editor, because I know that was but that was really time consuming, and so I don't really care about that so much. But if you can, like, let's say that your answer was x equals pi thirds. If you put x equals pi/3 on the computer, it is faster for me to grade, so I don't have to, I don't have to necessarily look at your work for that, although I still might look at it to make sure you're not just be like, oh, where did that come from? But yeah, if you can help me out and type in some answers, it makes my grading faster. But okay. I know that pretty much on every problem I need to look at your paper. So yeah, you don't necessarily have to write them in there, but if you do, it's helpful to me.
Okay, thank you.
So these take a long time to grade. So usually I have 2 screens, or I will have your computer thing open, and then I'll have your paper open, and I will go back and forth, and that usually works pretty well. So, okay, other questions? Okay, by raise of hands, did you guys, who noticed that I put up a review yesterday? Okay, who didn't notice? Oh, I put up a review yesterday. Do you want me to pull it up? Because I think I already have it open, don't I? Do I have it open? Yeah, I do. There it is. And it was all multiple choice, and it's, I don't know, I probably won't do very much multiple choice on there, but maybe I should show you where I found that. So if you go to Math 1060 assignments, you go down here to exam reviews, and then I've got the new exam review there. So 3.1 to 3.6. Don't forget 1.6 because we did that one as well. So so does anybody have any questions from the review that we'd like to go over, or do you want me to just pick some random problems and see if you can do them?
I have a question.
Okay.
I haven't had a chance to go over it, but just looking at reviewing it quickly, number 39. Anytime there's a K. Yeah.
Anytime there's a K.
Yeah, it freaks me out. So we could go over that.
Yeah. And so, by the way, yeah, and this came up before we started recording. So this is not x divided by x. This is what we call set notation. X such that x equals 2 pi thirds plus 2k pi, or x equals 4 pi thirds plus 2k pi. So that's just, I read answer A there. I don't know if that's the right answer, but we can do this one. So so this is a good one, and I will just say, Nicole, excellent question, because I think most students get messed up with the 2k pi. So just remember, k is an integer, and so we know this is actually fairly easy, right? If I open up a new page here, in fact, I'm going to try to put these side by side so we can see. So this is fairly easy. If I take the cosine of x equals square root of 3 over 2, square root of 3 divided by 2, it's fairly easy to remember, to know that we take the inverse cosine, right? So x equals, what's the inverse cosine of square root of 3 over 2?
The pi over 3.
Pi over 3, okay. And then, of course, it repeats. Let me think about this. So the cosine is positive. Well, this is when I need to draw my picture again.
Or is it pi over 6?
Yeah, it is pi over 6. You're right.
Oh, it's cosine. Yeah, thank you.
Yeah, pi 6. Okay, but this repeats. Here, I'm going to do it this way. All students, click, students take calculus. Okay, so the cosine is positive in quadrants 1 and 4. And this is pi 6, so that's going to be this angle here, and it's going to be this angle here, roughly. Okay. So, so your answer is going to be pi 6, and then, so you could write this as negative pi 6, right? Although we don't necessarily like using negative angles. So that's 2 pi minus pi 6, so that's 11 pi 6. Right? 11 pi 6. And of course, that's going to repeat. Maybe I'll put it over here. So this will repeat every 2k pi, right? Plus 2k pi. For both of those. So that would be answer D, right?
Okay, that makes sense.
Yeah.
Thanks.
All right, any others? You want me to pick some random problems that I think were good that,
Yes, please.
okay, that students will struggle with? Oh, we got to do number 46 because I know Ivan will like that one, right, Ivan? Ivan's not on camera, so I can't see him smirk. Water wheel rotates through the angle theta with the water level L behind the wheel according to the equation where L is measured in inches. Determine the values for the where the water level is 0. Find exact values. Do not use your calculator. I wonder if I can copy that. Can I copy that? It worked out pretty well, except for that's a cosine squared, right? 1 minus the sine of theta minus 2 cosine squared of theta. This one's really good. This is a really good hard one. So that's squared. Okay. So where the water level is 0, what would you replace the L with, Ivan? And if you're on mute, if we can't hear you. Ivan, did you walk away? Okay, Jackson, help me out. What would you replace the L with if we wanted a water level of 0?
With 0.
0. Oh, we just got Ivan on text. Oh, okay, sorry about that. All right, so 0 equals the everything in here. I'm just going to change the L to a 0. Okay, so now how would we take care of this?
Is this for me?
Anyway, I'll throw this out for anyone. But yeah, you can take it, Jackson, if you want.
I just added the sine and 2 cosine squared of theta to the other side to get rid of the negative and set equal to 1.
You could do that, but I would rather leave them where they are.
Okay.
So let's open this up to anyone because I think this is it's probably hard to figure out what you would do first, and then when I show you, you'll be like, "Oh, duh! I should have remembered that."
Is it a?
You want a hint?
Can we factor it? Looks like a quadratic.
It is a quadratic, but the problem is we've got a sine and a cosine, and those aren't easily factorable.
But we have a cosine squared.
What you can do, it's with a cosine squared of theta, it's a power reducing identity. You can actually make that into set that in terms of sine.
Okay.
I believe. Let's see, hold on.
So power reducing isn't what I had in mind. That might work, but there's a different identity that I think would be better.
We can have cosine squared. We can replace that with 1 minus the sine squared.
That's the one. Okay, that's the one I was thinking of. All right. So
yeah.
we're going to rewrite this as 0 equals 1. Ooh, didn't mean to press the help button. Now you're in my way. Here, I guess we can make it big anyway. Okay, so 0 equals 1 minus sine of, and I'm going to change it to x because I hate thetas. Sine of x, and then we're going to have minus 2 times 1 minus the sine squared of x. Okay, so when we do that, we can distribute that too. So this becomes minus 2 plus the sine squared of x. Now, and then this is, I'm just going to copy that around. Okay, so I've got 1 minus sine of x minus 2 plus the sine squared of x equals 0. So I'm still have my 0 equals, and I'm going to flip this around to be the sine squared of x minus the sine of x, and 1 minus 2 is minus 1. Okay. So now I've got a nice quadratic in the sine, right? Now, I don't remember who it was, somebody said factor it, and so now that we have it all in sines, it's going to be much easier to factor it, right? Now, some of us are still going to have trouble factoring it, okay? So another thing that you can think of, we kind of talked about this in class, but I didn't emphasize it very much, is we can do u substitution. Let u equal the sine of x. And so if I do that, then this becomes u squared minus u minus 1. Oh, is that factorable?
It's not factorable.
Oh, it's not factorable.
Yeah, if you use the AC method, you got a positive 1 and a negative 1, which will leave out the sine of x, the negative sine of x in the middle.
So it's not factorable. I was thinking it was. So what do we do when it's not factorable?
Use the quadratic equation.
Use the quadratic equation. Okay, so I'm still going to leave this as a u squared. So negative b, you guys still remember the quadratic formula?
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
So Texas has it down. Here I'm going to watch people. Who does not remember the quadratic formula? Okay, good. Y'all remember it? Good. There's a few people off camera, so you have to speak up. Plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now in this case, instead of I should say x equals, I'm going to say that u equals, and remember that u, so I could substitute back and I could say that the sine of x equals, who do I want to do this? How about Cameron Ravert? We haven't talked to you for a few days, have we? You can take care of it though, right? You good?
Just the quadratic formula, just plugging it in.
Right.
So, I mean, what b would be, would it be negative 1? Because it's minus u, right?
So minus 1, so it would be positive 1, right?
Yeah. I was just making
Minus.
sure. And so then it would be plus or minus the square root of negative 1 squared.
Which is 1.
Mm-hmm. Minus 4 times 1 times negative 1, which is just negative 4. Wait.
Okay. All over
2 times 1.
Okay. So now, the one thing that we have to remember here, we've got the sine of x equal to all this. And so remember that it can't be greater than 1. So we might be throwing out some answers here. So 1 plus or minus square root of, what does that become in the inside?
Wouldn't it just be 5?
5, thank you. All over 2. Okay, so let's think about this for a minute. Now, so 1, here I'm going to do this. So 1 plus the square root of 5 would be 3 divided by 2. So that's not going to work. Not work, because that's going to be greater than 1, right? Because we're going to end up with 3 divided by 2, and that number is greater than 1, so it's not going to work. So the other answer we have here is 1 minus the square root of 5, which is going to be negative 1.23, but when we divide that by 2, that's going to work. So this divided by that that's less than 1, so that's going to work. So in this case, we can throw out the plus answer. We've only got the minus answer. So if I'm leaving this here, because it does say you're not supposed to use a calculator, and I know that I cheated a little bit and used a calculator, but I wanted you to see here, you've got to know that the square root of 5 is going to be, that this is going to be too big, okay? So going back here, so I've got 1, so the sine of x equals 1 minus the square root of 5. And so when we're doing this answer, we get to throw away the plus 1 there. And so now we need to take the inverse sine, of both sides. And so x is going to be, or theta, equals the inverse sine, or arc sine of 1 minus the square root of 5 divided by 2. So that's the answer, because it does say do not use a calculator. That's the answer I'm looking for. Okay. Now, if you do use a calculator, equals the arc sine of this, just so you know. And that's going to be in radians, so it's going to be negative 0.66 radians. I don't know what that is. But this would be the answer I'm looking for. In fact, I believe that's what the answer is in the back, right? Which one was it? 46. Actually, they're getting a different answer. How's that possible? Pi half, 7 pi 6, 11 pi 6. Doesn't look right to me. Did I make a mistake somewhere? I don't think I did.
Isn't a supposed to be 2? Because then you get square root of 9 and everything's over 4.
So negative 2 plus sine squared. So that's sine squared. So 1 minus 2 is negative 1.
Oh, wait. Go back. It's plus 2 sine squared of x.
Oh, is that where I messed up?
Yeah. Because you forgot to multiply.
Ah, that's right. So it should be 2 sine squared. Well, now it's factorable. Yeah. Then this becomes 2u squared. And now it is factorable. Okay, so yeah, that's where I messed up. Okay, so then this becomes 2u minus 1. No, plus 1. And u minus 1. So that's 2u squared minus 2u plus u. Yeah, there we go. And so then this becomes 2, so we back substitute 2 sine of x plus 1, 0, or sine of x, that one's going to be equals 1. So this one's going to be x equals pi halves. That was easy. This one here, okay, so we don't need the quadratic formula because now it's factorable. Okay, so then this becomes 2 sine of x equals minus 1. And we'll divide by 2, so then the sine of x equals 1/2. And then, 1/2. The inverse sine of x is going to be x equals, this is pi 6 or 7 pi 6. Okay. Well, now who needs a calculator for sure? I guess having said that, if it was not factorable and you had to use the quadratic formula, that number that I had there, that would have been correct. Okay, so those are the right answers, aren't they? Yeah. Wait. 7 pi 6 and 11 pi 6. Oh yeah, because I got my numbers wrong. I got my sine and my cosine mixed up. Okay, so there you have it. Okay, any others? Oh, this one's a good one because you guys will not. This is more college algebra. I was thinking we should do, so here, let me choose. You can either do we can either do number 50 in class. I think I started with a bunch of identities though. How do you guys feel on your identities?
I don't know who I am.
You don't know who you are. You've lost your identity. Okay, well, who don't I pick on very often? Mason, I'm going to let you pick which problem we can do next.
That's too much pressure.
Too much pressure?
Okay, let me look.
Which problem do you, because the beginning of the test is identities, and I think people have troubles with those.
Okay.
Or we can do an inverse. We can do problem 50 because I'm pretty certain that if I put problem 50 on the test, a lot of, especially if it's not multiple choice, a lot of you are going to freak out about that one.
Okay, let's do 50 then.
You want to do 50?
Yeah, let's do it.
Find the inverse function of that. Find inverse function of, now I can't remember what the one, f of x equals 3x minus 2, oops, 3x minus 2 over x plus 5. And if you have any trouble doing this one, Mason, Nicole will help you. I know that she wants to do this one, don't you, Nicole?
I didn't know I was doing it. Let me write it down real quick.
Okay, there you go.
Hopefully you got it, Mason.
Hopefully.
Nicole's rooting for you, Mason.
We're going to be in deep trouble tomorrow morning. Okay,
Yeah.
so you make, so f of x is y, and then, or is x, and you switch
So
The x is on the right
equals
side, so y.
3y minus 2 over y plus 5. Okay.
Nicole, got any ideas?
Already? Do you, I don't know if that's right, but would you multiply both sides by y plus 5?
Oh, good answer, Nicole. Okay, so both sides. So on the left side, we're going to get what?
X and then y plus 5.
So I'm gonna multiply through xy
5x.
Plus 5x equals just simply 3y minus 2. Okay.
Okay. Then you add 2. Right.
You could add 2. Okay, since you said that, I probably wouldn't, but it's okay. It's not wrong.
Okay.
3y, so you're going to have xy plus 5x plus 2 equals 3y.
See, if there wasn't a y on the other side, I just divide by 3, and that would be what y equals. But
yeah, that's why
that's
this
the problem.
one makes it hard. We
Yeah.
need to get all the y's on one side. I gave you a hint there, though. So how can you get all the y's on the same side? That's your hint.
Wouldn't you just divide y from xy? So
No.
No?
Don't
Well,
divide.
wouldn't you
That
move
would be a bad
xy
idea.
to the side with 3y and then you'd factor out a y?
Yeah, you could subtract the xy from both sides. Okay. So in this case, we've got 5x plus 2 equals 3y minus xy, right?
Right.
Then, so I don't remember who spoke up, but they were right on track. Do you remember what that person said?
Oh, you factor out the y.
Factor out the y. You knew that, Nicole, didn't you? She's laughing. Okay, so now, so we're factoring out the y, so I'm going to have left y, and I'm going to have left what?
3 minus x.
3 minus x, and still got this here, but nothing's changed there. Okay, so now what?
Now we can divide by 3 minus x.
Yay.
Okay.
Okay, so then this is going to give me 5x minus 2 over 3 minus x. I'm going to underline that. Sorry, the equals is underlined. Equals y, but we're going to change the y to what?
The inverse of f of x.
F inverse of x. Okay.
Cool.
Bing. Okay, so that's going to be the hard part. Now, the other issue with this problem, okay, so 3 minus x. So you're probably not going to get a multiple choice there, but the answer would be D. But my question is, without looking at that, because if this is not multiple choice, can you find the domain and the range F inverse? So Nicole, here we're gonna let Mason off the hook. Nicole, can you do that?
Domain and range is not my favorite.
Yeah. Domain should be really easy though.
Should is a keyword. Is it the denominator?
Yeah.
Is that what? Okay. For the domain, so it'd be 3 minus x.
3 minus x cannot not equal what? The denominator is a problem when it is
0.
0. So 3 minus x cannot equal 0. So therefore, x cannot equal
3.
No, you're right, 3. X cannot equal 3. So that's your domain.
Okay.
Okay, so now the range might be a little bit harder, but one way to think about it is, remember these swap over here. So what would be the domain here back in the original problem?
The domain would be that x cannot equal -5.
Okay, so now this becomes your range. So y cannot equal what?
Oh, sorry, -5.
-5. Thank you.
So I was taking notes. A lot of arrows.
So those are your answers there. X cannot equal -3, y cannot equal -5.
Okay.
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 Which I think is what they said. Yes, that's what they said.
On the test, if we're to do it like from -infinity up to, but not including 3 for the domain for f inverse, or not -3, but +3, and then not including +3 to +infinity, would you accept that notation on the test? Okay.
Yeah, that's interval notation.
Okay.
It seems like they're a lot bigger on interval notation at UVU than I am, but yeah, that's fine. I think this is simpler, but
okay.
Okay. All right, we got 6 minutes left. So I know Chris has bad internet. Is there anything that you would like to talk about, and hopefully we can hear your answer?
We can go over number 2.
Number 2. Have we lost some people here? I think we lost some people here. All right. Number 2 on here. Express the given trigonometric function in terms of the indicated function. So the cosine of theta in terms of the secant of theta. So right, I read that again. Right, the cosine, I'm going to put x because it's easier, in terms of the secant. Did you have any ideas? This is actually a lot easier than you think, I think.
Yeah, I had a feeling too, but let's see. No, I have no ideas.
No ideas?
I
this
have
one
an
should
idea.
be something you have memorized.
I know cosine of x is equal to 1 over cosine of x, which is secant.
So cosine of x 1 over the secant.
Yeah.
See how easy that was? Boom, you're done.
That's it.
Was it? Answer D.
Okay.
Dang, that was really easy.
Nice.
You saw all this other stuff and said, "Oh, it must be hard."
Yeah, that's probably it.
That was probably the easiest one on the test.
Okay.
Okay.
Because there's something I just
Yeah, you should have that one
like,
memorized.
all my waiting all night and I couldn't pull them up.
All right, who else do we want to pick on here? Oh, Ivan, you're back on camera. Welcome back. Cameron Daly. You want to pick one?
I actually haven't looked over the review yet, but
Here, I'll scroll through kind of slowly, and then you can stop me when you see something that looks ugly.
we could do 4 or 5.
Which one?
Let's do 4.
4. Simplify the expression. Yeah, that one does look kind of complicated. That's a good test question right there. I don't think I can copy this. We're going to find out. Oh, that worked better than I thought. Cosine squared over the sine squared plus. Oh, that actually worked better than I thought. So, plus cosecant sine of x. Sine of x, but I'm on the phone, okay? Can you talk to me about 10 minutes? All right, oops. Okay, so how would we simplify this one? This says simplify, right? Okay. And these are squared, right? Oh, I need to make sure that's squared. So what do you guys think?
Well, cosine squared of x, can't you change that until 1 minus sine squared of x?
You could.
Or would you want to do that?
I don't know. What's the cosine squared divided by the sine squared?
Cotangent?
Cotangent squared of x. And what about the cosecant and the sine?
Would those just cancel out?
Yeah, because cosecant's 1 over the sine, right? So this just becomes plus 1. So cotangent squared of x plus 1. Oh, that's not one of the answers they chose there, though. Oh, except for, what's the cotangent
It's the
squared
cosecant
plus
squared.
1? Yeah, that equals the cosecant squared. Boom. X. So that would be answer D right there. Boom. All right, well, we're out of time. So what do you think of that one, Cameron? Was that too bad or was that not too bad?
Yeah, that wasn't too bad.
Okay. All right, so test, I get to write the test now, and few multiple choice, if any. Take it from 8 to 9:30.
Can I take it after work?
You want to take it after work? Okay, send me an email and we'll work that out. But yeah, please, I wish you'd let me know that sooner. But yeah, that's fine. I haven't written it yet. But yeah, send me an email to remind me and tell me what time you want to take it.
Okay.
And if anybody else, if you have any issues with work or something,
I usually come to my job to take it. So if I come before, there's going to be a lot of people, but after 5, everybody leaves. So that's why it's easier for me to do it, because that's what I have the proctorio in my work computer. For some reason, laptop doesn't allow me.
Yeah, I don't want you driving home and getting in a car accident like last time.
Yeah.
All right. Okay, any other questions you guys have before I let you go? Did everybody stick around here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, we only lost one person. I don't remember who that was. So, okay. Well, good luck, study hard, ace the test, make me proud. And we're more than halfway through class now. So just as a quick reminder, we'll have another test 2 weeks from tomorrow, and then 3 weeks from tomorrow will be the final exam. So I think I've built in a day or two of review. So and I think we got lucky because, I mean, I guess whether you call it lucky or not, we weren't off for the 4th of July or the 24th. Usually we're off one or both of those days. So I think that builds in a couple of extra review days. So that's nice. So, all right. Well, does anybody want to stick around and hang out with Texas? And you can do that. So, but I'm going to stop recording, and thanks again. And please, please ace my test. Okay. All right. Good luck. We'll see y'all.
Thanks.
See ya.